Hello, class. So this is the last video for section 4.9. It's nothing new. The only thing is that there are some particular type of problems which are called initial value problems. So what's an initial value problem? You want to find a solution to this problem. P prime of t equals 10 to the e to the negative t with the condition that p of 0 equals 100. So this here is actually called a differential equation. Why is it called a differential equation? Because we have an equation involving a derivative of p. What's a solution to a differential equation? Well, the solution to a differential equation is a function that when you plug it in, you get equality, right? So the solution to this differential equation is a function, let's just call it p of t. And then in this case, when we plug p of t, we want to make this equality true, right? So that means a function p of t whose derivative is 10 times e to the negative t. That's a solution of a differential equation, which is what this thing in red is. Why is this called an initial value problem? Because we add on a restriction on p. P can't be any function. It has to be a function that specifically also satisfies that when you plug in 0, you get 100. So how do you solve a problem like this? Well, you first solve this part. So you do this first, and then you solve this part. Okay. So again, to find the first part, we want a function whose derivative equals 10 e to the negative t. Well, that's the same as asking for an antiderivative. And in fact, we can make it more general and just find all antiderivatives. So the first thing you want to do is find all antiderivatives of 10 e to the negative t. And again, the variable is t, so you use dt. Okay. Now, what is this going to be equal to? Well, remember that if we want a function whose derivative is e to the negative t, well, we know that the derivative of e to the negative t is itself times a constant, right? So it makes sense to work with something that looks like, so we're trying to find an antiderivative. So let me use green. It makes sure to work with a function that looks like, a constant times e to the negative t. Why? Because the derivative of this is going to be, well, the constant, then by the property of the derivatives of an exponential, you just bring the exponent down and you leave it as it is. So this function, c to the e to the negative t, c times e to the negative t is almost what we want, but we want c times negative 1 to be equal to 10. Okay, that means we can just let c be equal to negative 10, because then negative 10 times negative 1 is going to be 10. Okay. What does that mean for us? Well, the integral of 10 e to the negative t dt, and here we could have also just moved the 10 outside, right? Because remember, that's one of the properties we have. That probably would have been easier. But as we found, this is going to be what? Well, we found that it is, let me write it here. C has to be negative 10, so negative 10 e to the negative t. So negative 10 e to the negative t plus a constant. Now, we're not done. Right? This is all antiderivatives of 10 e to the negative t. The second step is we want one who specifically satisfies p of 0 equals 100. So we want p of 0 to be equal 100. So I should have used p before. Let me just use it here. But now we have that p of t equals, this is all antiderivatives. We want it to satisfy p of 0 equals 100. We can just plug that in and solve for c. Being that I can plug in 0, okay, so negative 10 e to the negative 0 plus c, this should be equal to 100. We can simplify. E to the 0 is 1, so we have negative 10 plus c equals 100, from which we get, from which we get, we'll add a 10 to both sides, c equals 110. So what is the unique function whose derivative is 10 e to the negative t, and that satisfies, this condition that p of 0 equals 100? Well, it's the function, negative 10 e to the negative t, where c equals 110. And then that's the answer. That's how you solve an initial value problem. Right? First do this part, where you find a function whose derivative is 10 e to the negative t, same as finding the indefinite integral, because you can just find all of them, might as well. And then make sure that you find one that specifically satisfies this property.